that happen, how confident can we be that drug A is superior? That's where the p-value comes in. P-values are numbers between 0 and 1 that, in this example, quantify how confident we should be that drug A is different from drug B. The closer a p-value is to 0, the more confidence we have that drug A and drug B are different.
Okay, and just remember, okay, the largest number p-value, that is 1. That is 1. We can consider 1 is 100%, and it means two groups are completely overlapped. Two groups are completely overlapped. Okay, then, and the smallest number of the p-value is 0. Thus, we can say the p-value is between 0 and 1. And if you want to find the difference, especially the term is significant difference or differences in plural, the p-value should be close to 0. I think the 0.05 is the minimum requirement. It depends on different experiment design. In the future, when you serve in a company doing some business marketing or some promotion, you need to know the details like this. And
yes, how small does a p-value have to be before we are sufficiently confident that drug A is different from drug B? In other words, what threshold can we use to make a good decision? In practice, a commonly used threshold is 0.05. It means that if there is no difference between drug A and drug B, and if we did this exact same experiment a bunch of times,
okay, and here I think that this video, the material is really good. Just memorize this number, p-value. Actually, different tests we can calculate the p-value. Previously, last week I told you how to calculate by the online applications to find two groups or three groups to compare the p-value here. Okay. Oh, sorry. And let me have.
And only 5% of those experiments would result in the wrong decision. Yes, this is an awkward sentence.
Okay.
So let's go through an example and work this out one step at a time. Imagine I gave the same drug A, to two different groups. Now, any differences in the results are 100% attributable to weird random things, like a rare allergy in one person or a strong placebo effect in another. In this case, the p-value would be 0.9, which is way larger than 0.
Okay, let me stop here. We can see that the p-value will be 0.9, and that is very close to 1. Just remember, the p-value, larger number of p-value is 1. 1 means 100%. The two groups are completely overlapped. They are the same. In other words, they are the same. But when the p-value is 0.9, it's a big number, very close to 100%. We can consider it's 90%. And it means those two groups are no significant difference between those two groups. Again, if you want to say, okay, $1, my parents created those oolong tea, they can reduce your blood pressure, especially for some hypertension. They can drink my parents' oolong tea to lower their blood pressure. Okay, I will ask, do you have any scientific evidence? Sure, we try the clinical experiments like this. Can you show me the data? Sure, I can show the data. Can you calculate the p-value? The p-value is 0.9. Okay, it is worthless because there is no significant difference between them. Okay, get it? Let me continue to play this one.
0.5. Thus, we would would say that we fail to see a difference between the two groups. If we repeated this same experiment a lot of times, most of the time we would get similarly large p-values. However, every once in a while, all of the people with rare allergies might end up in the group on the left, and all of the people with the strong placebo reactions might end up in the group on the right.
It's funny. Why? Because it says with the strong placebo reactions. What does it mean, placebo? Placebo. Because the people who joined the test or the patients, they didn't know they used the real drug or a placebo. They didn't know. So in the future, I would say there are many clinical trials. We said double blind. Double blind, it means the doctors don't know the drug is a real drug or placebo. And the patients or the people who attend the clinical trial, they don't know which one is real either. So there is a very famous test method, we call it double blind and placebo. That is important because they want to know the placebo effect. How large is it? Does it affect the evaluation on the new drug? Okay, then we still have 5 minutes. Let me finish this section and we can move to the next one.
As a result, the p-value for this specific run of the experiment is 0.01, since the results are pretty different. Thus, in this case, we would say that the two groups are different, even though they both took the same drug. Oh no, it's the dreaded terminology alert.
Okay, here another special case, getting a small p-value when there is no difference is called a false positive. Okay, again, cured and not cured, and the p-value is 0.01. I know that is very small, very small, but this kind of it can be categorized as the false positive. The false positive.
Getting a small p-value when there is no difference is called a false positive. A 0.05 threshold for p-values means that 5% of the experiments where the only differences come from weird random things will generate a p-value smaller than 0.05. In other words, if there's no difference between drug A and drug B, 5% of the time we do the experiment, we will get a p-value less than 0.05, aka a false positive. Note, if it is extremely important that we are correct when we say the drugs are different, then we can use a smaller threshold, like 0.00001.
Generally, as I know, 0.05 is the common threshold, the common criteria for setting the experiments, and the next label is 0.01, and the next label is 0.005. But I never see anything like this. There are 1, 2, 3, 4, 4 zeros between the number. I think is actually in the medical test. Generally 0.05, smaller, or 0.01, or even 0.005. That is enough. Okay, then let me finish this video.
Using a threshold of 0.00001 means we would only get a false positive once every 100,000 experiments. Likewise, if it's not that important, for example, if we're trying to decide if the ice cream truck will arrive on time, then we can use a larger threshold, like 0.2. Using a threshold of 0.2 means we are willing to get a false positive 2 times out of 10.
Okay, again, the 0.02 p-value 0.0, it means 20%. 20%. Okay, and here it means the probability to get a false positive is 2 in 10. That is 20%. If you can accept this ratio, I think you can set the threshold of the p-value at 0.2. That's enough. But generally, in the scientific field or in business field, 0.05 is the common threshold of p-value. Okay, then let me finish this video.
The most common threshold is 0.05 because trying to reduce the number of false positives below 5% often costs more than it's worth. So, if we calculate a p-value for this experiment, and the p-value is less than 0.05, then we will decide that drug A is different from drug B.
Okay, again, I think you can forget everything. You can forget all concepts, but this value, try to memorize it. p-value, when p-value less than 0.05, that is the common sense. There's a common sense, the criteria for many fields. We will decide the drug A is different from drug B. Done. Okay, let me have different example. One daughter's parents created a product called health oolong tea, and the oolong tea, according to the clinical trials, then we prove that the p-value is less than 0.05, and you can drink the oolong tea. It may lower your blood pressure, or something like this. Okay.
That said, the p-value is actually 0.24, so we are not confident that drug A is different from drug B. Bam! Okay, before we're done, let me say 2 more things about p-values. Unfortunately, the first thing I want to say is just more terminology. In fancy statistical lingo, the idea of trying to determine if these drugs are the same or not is called hypothesis testing. The null hypothesis is that the drugs are the same, and the p-value helps us decide if we should reject the null hypothesis or not. Small down. Okay, now that we have that fancy terminology out of the way, the second thing I want to say is way more interesting. While a small p-value helps us decide if drug A is different from drug B, it does not tell us how different they are. In other words, you can have a small p-value regardless of the size of difference between drug A and drug B. The difference can be tiny or huge.
Okay, so let me replace part. You can have a small p-value regardless of the size of difference between drug A and B. Okay.
Between drug A and drug B, the difference can be tiny or huge. For example, this experiment gives us a relatively large p-value, 0.24, even though there is a 6-point difference between drug A and drug B. In contrast, this experiment, which involves a lot more people, gives us a smaller p-value, 0.04.
Okay, and in this video, drug A cured 5,005 people, but not cured almost double the number. And in drug B, 4,800 people are cured, but not cured is also doubled. And the p-value is 0.04. Okay.
Even though, given the new data, there is a 1-point difference between drug A and drug B. In summary, a small p-value does not imply that the effect size or difference between drug A and drug B is large. Double down. Hooray! We've made it to the end of another exciting stat quest. Did you like this step?
Okay, okay, we finish this video, and if you want to find this video, is on my website on the syllabus. You can check it here. The week 13, May 15th, and the video is here. I think that the video is very clear to explain this part to this experimental. Okay, so sorry I postponed the break time, so have a 10-minute break, then see you later.